So, ladies and gentlemen, as you might have heard, Theo is currently being calibrated, and I wanted to show you briefly how this process works. In this shot, this is more like a demonstration of the tools we have. I don't really want to bore you with the parameter estimation details. So, what do we have here? This is a simple A2O plant, and let's just see how it behaves. We have configured a simple dynamic simulation running for 200 days. And just monitoring the phosphorus concentration in the aerated tank of the system. It looks quite normal. Well, until it does not. What's actually happening at around 130 days? Well, that's the interesting thing to find out. So I guess the first thing should be to check out that phosphorus concentration numerically. So we navigate to the state variables. Let's just apply a filter quickly. Yep, orthophosphate, it's a minuscule number, so but that's still a symptom. We need the reason behind it. And that's the point where people usually start wishing for a time machine. If we could go back to that inflection, we could catch the culprit red-handed. And the good news is that actually in Theo we do have a time machine. If you start moving that slider, you can go back with the simulation at any previous time instances. You can check out any values because these are updated live. And let's see what actually is contributing to the phosphorus concentration back around 97 days. Well, PAOs are eating phosphorus quite all right. Let's just approach the singularity a bit better. Oops, there we have it. Look at that. Brush-it precipitation becoming more and more dominant as we approach the singularity. And I guess if we could position our time machine exactly the point of the singularity, it would take over the whole story. So let's just check out how much of this brush-it we have in the system and how much it contributes to the suspended solids. Again, contributing variables. We have almost 4 kilos of suspended solids in the system, a quite healthy value. Some bugs, some particulate undegradable organics, and there we have it. There we have it, and that's an unusually large concentration, and I guess it will be even larger if we move backwards, forward with the simulation. Yep, it actually starts dominating the system as all the bugs die in absence of phosphorus. All right, before we do anything, let's just make sure that it is indeed the brush-it. Let's just add one more time chart and check out the dynamic profile of this component. Again, back to state variables, adjust the filter, add the variable, and there we have it. Yep, it actually blows up pretty nicely. There is the inflection point, and when the phosphorus runs out, the precipitation slows down. All right, as a quick help here, let's just knock out the precipitation of brush-it completely. So we go to the model parameters, find the parameter which controls the precipitation rate, reduce it by an order of a magnitude. This is, of course, not a final fix, just a quick adjustment, which could actually support our hypothesis around the brush-it precipitation. As you can see, it's still growing, but there is no phosphorus depletion because the concentration order of magnitude is completely different. And there we have it. As I mentioned, this is of course not a final fix, just a quick demonstration of how easy it is to catch certain model details in Theo. Well, thanks for watching. Wish us luck with the calibration. And if you have questions, you know where to find us. Thank you.